Right. So in terms of trig identities, right, we do need to know factorization thoroughly because it assists us in terms of these trig identities, number one, and in terms of general solution, right? There are questions in general solution whereby you have to factorize the trigonometric ratios. So if you can't factorize, it's a bit difficult, and it's not always, I don't know, it's running always to the quadratic formula can be time consuming. But if you can learn this method and apply it as fast as you possibly can, you can get it. I actually tested it with my grade 10 learner. I think the average time it took was 3 minutes using this formula, but you can actually take much less. You know, it's still young, and then you guys, you know these things. So yeah, I was trying to show you here that the way of using this method just involves you taking the middle term, dividing it, remember. Oh, by the way, now that it's a second recording, just as a disclaimer, right, to say this method is not my own, that I invented on my own, but rather it's from this very brilliant professor here, Professor Po-Shen law, right? I'm hoping I'm pronouncing it correctly. And another thing, as a disclaimer again, please, when they give you questions in what you call in your exam, right, and then they write in the brackets that like maybe they'll give you negative x squared, right, minus x minus 3 is equal to 0, then they write in brackets 2 decimal places. We do know that these type of questions we usually have to use the quadratic formula because there are no factors that we can think from our head that will satisfy the equation. But if you use that formula, you will get the factors. But then don't use it, please. Don't use it when they say 2 decimal places. Go to your quadratic formula because it's the one that is standard that you are tested on. Please, I wanted to make that clear there. Yeah, I wanted to make it clear that when you see questions like this in your exam, please use the quadratic formula. You are advised to know how to use it. But I was just saying, on questions like this, whereby they give you, let's just say, they don't really say in brackets, you know, that you must use, like they give you x squared minus 4x and then minus 12, then they just say equal to 0. On this one, I know some people also use the quadratic formula. I'm not saying shift from that. Please also use the quadratic formula. But here you are allowed to use that method. Here, when they didn't say 2 decimal places, you are allowed to use that method. Are we clear? If even on inequalities, on all inequalities, you are allowed to use the method, except for special inequalities, like if I give you 3 to the power x and then I say maybe x is less than 0, oh sorry, maybe x minus 6, and then I say this should be less than 0. No, obviously for these ones, these are special inequalities. Again, it doesn't really work. The method works if I give you something that is able to be factorized and then I say maybe greater or equal to 0, then you're allowed to use the method. And just to go through the method again, of how we would factorize this part, right? Remember, we would say the middle term, right? You simply say the middle term divided by 2. The middle term divided by 2, you say minus u. Then you say the middle term divided by 2 plus u. You say should give you the last term or the third term, which is negative 12. Then remember I said it will always give you a difference of 2 squares. In this case, negative 4 over 2 times negative 4 over 2 should give you 16 over 4, right, minus u squared, because minus u times u will be u squared. So it usually is going to be in this format whereby it's a square, it will be a difference of 2 squares. You say is equals to this. So I believe 16 over 4 is simply 4, ne? It's simply 4. So your 4 minus u squared is equals to minus 12. Then your 4 plus 12 is equals to u squared, whereby here you will have 16, then you say the root of 16, your u will be 4. So therefore, when you factorize this, you're simply going to say x. In the first bracket, you're going to say minus 4 over 2. You're going to write it like that, minus the 4. And then you say minus 4 over 2. One of the mistakes I'm making, I'm hoping you have to have x. You have to have x. Then you have minus 4 over 2 and plus the u, which is 4. Right, then from there you put this in your calculator. Minus 2 minus, I think it should give you negative 6, and then here minus 2 plus 4 should be 2. So these would be the factors of that, you see. So you would have factorized it quite easily. If you're doing inequalities like this, you would say, oh, your critical values is negative 2 and 6, and then you know negative 2 6, you know the stuff now, right? You know the stuff. So I'm just saying that is a method we can use to factorize. But then if it happens that there is a certain variable here, then we would have to use we would have to look at it differently a bit. All right, so identities. This is the first identity that we have, cos theta minus 2 theta plus 2. Now let's see how everything will work out. Before we do identities, let's remember the tools that we must have. The first tool, or what we need to remember, is that tan theta is equal to sine theta over cos theta. Sine and cos always imitate tan, meaning if I have tan 2 theta, this will be equal to sine 2 theta over what? Cos 2 theta. If I had tan 3 theta, then I will have sine 3 theta over cos 3 theta. Then if I had tan squared x, this would be equal to sine squared x over cos squared x. So sine and cos just imitate whatever tan is doing, right? So we must know that. Number 2, let's remember that sine squared x, or theta, plus cos squared x is equal to 1, which means that sine squared x will be equal to 1 minus cos squared x. Where I see 1 minus cos squared x, I'm allowed to put sine squared x. Where I see sine squared x, I'm allowed to put 1 minus cos squared x. Similarly, cos squared x will be 1 minus sine squared x. Yeah, then that is it. You just have to know that those two tools, they are going to assist you. And then just remember your, additionally, right, remember your reduction formula, remember your double angle formulas, and then remember your compound angle formulas, and then just try to know how to factorize them. So let's see how we would prove this identity. The first thing to do is to work in the side whereby you see most of the information can be extracted from. So in this case, I do see that the side whereby I can extract information, it's like the left hand side. It's more juicier than the right hand side. So you choose the juicy side, right? So you say, okay, the left hand side would be cos theta minus cos 2 theta plus 2. You divide that by what? 3 sine theta minus sine 2 theta. And remember what I always say, the remedy for maths, the way to pass maths, is if you do a lot of problems. That is the only way, guys. When your teacher said you must practice, I think they didn't put it quite plainly. We must call a spade a spade. When they said practice, they meant that do a lot of problems on one topic, do a lot of problems on it, or in fact on all of the topics, do a lot of problems, so that you get used to the style of questioning, so that you get used to the method that you use to apply. Right, so this is what we have. And I always say that for identities, really, to be honest with you, it's like playing chess. You know, if you play chess, you would enjoy identities a lot. Nah, I'm not saying if you can't play chess, you won't be able to master them. I mean, I got you, by the way. I'm just saying, if you know how to play chess, you know why? Because the chess players, what they do is that they move 5 steps, 6 steps ahead of their opponent in an effort to win the game. They have to move and predict moves, right? Way ahead. So in a similar manner, on identities, you do have to predict what your outcomes will be if you do this, but you must do it in your head first before solving the problem, to be honest with you guys. For example, when I look at this problem, I want to take you through my own problem solving strategy. I look at it, right, and I'm like, okay, a lot is going on this problem, Shame. A lot is going on. And here I am in the exam, I want to avoid panicking, because if I panic, I'm going to be in trouble. I'm not going to get anything correct. So what can I do not to panic? I must try to see if I can move or think about 2 steps ahead of the problem. Usually, if you have a fraction, in one way or another, you would have to factorize the top part. You will also have to factorize the bottom part, so that there you create some stuff that are going to cancel each other. And when they cancel each other, they must result in the final answer. You understand me? So I'm already looking at the problem. I'm like, okay, I know that I have a fraction. First of all, I have a fraction. So because I have a fraction, I know I must factorize on top and then factorize the bottom part. And then after that, what I get, that will be, it should give me the right hand side or the left hand side. Right? That is the first thing. We must factorize. But how do you factorize? That is the question now. How do I put things such that I'm able to factorize them? There are 2 ways. You understand me? When you are factorizing, there are 2 ways. You can either have this situation. I'm going to write it in terms of letters. You can either have this situation. You can either have this situation, right, or you can have this situation. Right, you can either have the above or the below situation. And in most cases, the nice thing about, or you can have this situation, 2x squared. When you're factorizing, in most cases, you're either going to have to factorize a trinomial, or you're going to have to factorize a binomial. If you factorize a binomial, in most cases, it will either be a difference of 2 squares, or it will be whereby maybe you have something like 2x minus 2 or 2x plus 2, and then you can take out a common factor. Good people, I'm writing this in terms of algebra, but the very same thing, this is how it would look like in terms of trigonometry. For the first part, you would have something like maybe sine squared theta plus 2 sine theta cos theta, and then plus cos squared theta. Then you can either have, this is this part. Do you see it? It will mean x is sine, your y is what? Is cos. Or you can have this situation whereby you have sine squared theta plus 2 sine theta and then plus 1. What you see here, good people, is exactly this. because your sign is x, so you have x squared plus 2x. Or you can have cos squared theta plus 2 cos theta plus 1. This still this would be that. Exactly the same thing, whereby now x would be cos, right? In terms of these ones, right, you can have sine squared theta minus cos squared theta. Then in terms of this one, because here it means x is sine, cos is y, here you can have 2 sine theta plus 2, or 2 cos theta plus 2. In most cases, either your denominator or your numerator would be looking like one of these. Trust me. It is going to look like one of those. So it's a matter of recognizing. But there's also a method of using, like, saying maybe let x be sine and stuff. But you must substitute these things with letters. If you find that indeed maybe it is in that form, it can give you something like that in terms of the letters. All right, let's maybe not speak in Chinese that much. Let's try to actually solve this problem. So in terms of the left hand side, look what we have. You have cos theta, you have cos 2 theta, right? The thing is, you have cos 2 theta there. So that cos 2 theta, you need to change it. It's a double angle. You will need to change it to either, remember there are 3 forms of cos 2 theta. Remember, cos 2 theta could be cos squared theta minus sine squared theta. And then it could also be 2 cos squared theta minus 1. It could also be 1 minus 2 sine squared theta. So now, since cos 2 theta has 3 things, I think that is the only problem. Not to me, cos 2 theta. I take it as a lady. Hey, ladies, they need you to focus. So it's a bit problematic, good people. 3 things in total. So you don't know which one you must take. You see, but a man, sine 2 theta is much easier. Sine 2 theta, that one is for sure. It will always be this one. It does not change. It will always be 2 sine theta cos theta. No problem. Only one, then we are done. But the cos 2 theta, it's problematic. But you need to deal with it very delicately, softly, and nicely, intelligently so. So how do you do that, right? You have to think in terms of these variables. To say, whatever I will change cos 2 theta to must at least produce one of these situations that we see here. And in most cases, I will say to you, please note this, because it's always going to assist you. I will say to you, if here you don't find cos theta times sine theta, like as a pair, if you don't find them as a pair, right? If you don't find them as a pair, please do not use this one. You hear what I'm saying? If you don't find them as a pair, like if you don't find cos attached to sine, if you don't find such thing, either sine theta times cos or cos times sine, do not change cos 2 theta to the first one. Listen carefully to me, okay? So, but Lighting, if I'm not supposed to change it to that one, where must I change it? What must I do? It's very simple. Whatever you see here, change cos 2 theta to that one. If here I had a sine, I would change cos 2 theta to this one. If here I have a cos theta, I'll change cos 2 theta to this one. That is the rule that you can always use. It always works for me. So let's do that. So I have cos theta, right? I say minus okay, I see there's a question. Okay, all right, so I said if you find yourself not having cos times sine, do not use this first one, this first expansion. How you use like how you choose between this one and that one will depend on what you have here. Do you have sine? Do you have cos? If you have cos, you're going to change cos 2 theta to 2 cos squared theta minus 1. But if I had sine there, I would change that cos 2 theta to 1 minus 2 sine squared theta. Are we okay there? All good? We change to what? It depends. Yes. Okay, yeah, it depends on what you have there. But as long as you don't have cos times sine, do not change to the first one. You'd be playing around in circles. So now that's why I was saying you must move like someone playing chess. Move strategically. So cos 2 theta, we're going to change it into 2 cos squared theta minus 1. Why? Because here we have a cos theta, right? And then outside there you have a plus 2, and then at the bottom, obviously at the bottom there you're going to change that sine 2 theta. That one is no doubt. You're going to change it to 2 sine theta cos theta. Perfect stuff. Then on the bottom, or on the top, right, on the numerator, you're going to simplify it. If you simplify it, good people, you should have negative 2 cos squared theta. Then you're going to have plus 1 plus 2. So you're going to have plus cos theta. Then you're going to have plus 3. Please do check it out. Remember, negative times 2 is negative 2. Negative times negative 1, it's going to be 1. And then that 1 plus 2, it's going to give you 3. Then this cos theta was positive. I write it here in the middle. Why do I write it like this? I must have it in the standard form. You see now it looks like this one. Now it looks like this. Just that there we have negative 2 here, and then here we have 1, and then here we have 3. But now it looks like this. Perfect. At the bottom you have what? You have 3 sine theta minus 2 sine theta cos theta. Right. Then you're okay. What is the next thing to do there? That is to simplify that part. Now is to factorize. Now you are allowed to use variables if you want. You can use variables there, as long as you won't forget to substitute the variable back. What do I like to do? What do you like to do, guys? Okay, let's use variables. You can just say let cos theta be what? Be x if you want. Okay, so that means you're going to have negative 2x squared plus x plus 3. Okay, but now you would also have to do the same thing there. It means your sine theta must be y now. So it means you're gonna have 3y minus 2y. Remember, this is y, this is x. So usually we call it xy, isn't it? So you're gonna have this. Right. Then once you have it in that form, remember I just substituted x where I see cos, y where I see sine. Now I can simply do what? Factorize. You see, now you see why it's important to know how to factorize. So usually when you factorize, remember here you must have a positive. So you're going to say negative, you take a negative out. But remember, we don't really stress ourselves in terms of taking out the negative as a common factor. If you can remember what I said, that you actually write the very same thing as it is. You write it as it is, and then you say, now I want to remove the negative, so I must divide everything by that negative. I divide everything by that negative, then I don't forget to take it out and multiply again everything by the negative, because I divided by it. Perfect stuff. Then at the bottom, what do you have? You have 3y minus 2xy. You can see that there is a common factor, right? What is your common factor there? It's your y. So what you do is that you write the very same thing as it is. Do not worry, write it as it is. And then simply, since your common factor is y, I want you to divide everything by y. After doing that, also multiply everything by y. Trust me guys, this is a nice way to find and to factorize using the highest common factor. So now, what will you have? You're going to have negative into negative 2 divided by negative 1 is going to be positive. And then here it's going to be negative x. And then here it's going to be minus 3. Perfect. Clean. And then here you have y. And then here what do you have? 3y. Y and y, they cancel. So you are left with 3. And then y and y cancel again. You are left with what? Minus 2x. Then you are good. Now you just need to ensure that you do not forget. You must factorize the top part. Hey, but now factorizing that top part is the one that is a bit of a headache, right? So that's why we usually run to the quadratic formula, of which I don't mind. You know, we can actually do that. If there's anyone there with the formula in near them, please do use the quadratic formula then. But if ever you want to do it in a remember using the method I just shared right now, then you can also do it, just that now because there is a 2 and then here, you know, 2, I can divide everything and then it will give me some nice values to give me fractions. So it makes it a bit interesting, but you can still do it. How you can still yeah, so this is what you can do, but remember, use the quadratic formula aside, guys. So you have 2x squared minus x minus 3. You're going to use what they call division and multiplication method, whereby you divide by 2 here, you multiply by 2, you have x squared minus x minus 6, and then after that you factorize this one. Now this one, factorizing it, if I can just quickly do it here. If you can remember, factorizing this, meaning I'll take the middle minus u, then I would say the middle one again plus u must give me negative 6. I think we did it before, but you will have so what you would have is minus half times minus half, that will be 1 over 4, and then you're gonna have plus 6 is equal to u squared. Then I think 1 over 4 plus 6 gives you what?
25 over 4.
Nice. 25 over 4. It will be your u squared. Now when you take the root both sides, it means that your u would be equal to 5 over 2. Then when you factorize this, it means you will say x, the first bracket is minus half. You have minus half minus u, of which is 5 over 2, and then x again. Then you have minus half, then you say plus the 5 over 2. So that should give you what? Minus 6 divided by 2 is minus 3. And then 4 divided by 2 is 2. So you should have this. However, because you actually divided and multiplied by 2, you do the same thing here, you do the same thing there, and then your answer should be 2x minus 3. And then you should have x plus 1. So therefore, when you factorize, it should be like this. My quadratic formula people, did we get that?
Sir?
Yes, ma'am.
I got my first x as 3 over 2 and the second one is negative 1.
Aish. And you know that is the problem of a quadratic, because now quadratic gives you fractions, and when it gives you fractions, right, it's because already here it's solved for you. The calculator solved for you to say that it will be 2x minus 3 is equal to 0. which is 2x is equals to 3, which is x equals to 3 over 2. So how do you write that as a bracket? I know you'll want to say this as a bracket, but it's fine. Just make sure that the denominator you multiply by, you just take the denominator out. We call it sliding the denominator. Just slide the denominator and multiply it by the x, so that you have 2x minus 3. Okay, so if I get 7 over 3, same thing, I'll just say this is 3x minus 7. If it was plus, 3x plus 7. Okay, I hope that is okay. So now that we would have factorized that, good people, that is what we are going to write here to say now, okay, the answer for this top part, it would be negative, then you say 2x minus 3, and then you say x plus y, then you divide by now check, guys, you see this is 3 minus 2x, and then here you have 2x minus 3. If you can remember, those brackets are actually the same. So what do you need to do? You actually need to make sure that you write them in the same way. When I'm with my grade 10s, I tell them that you want this bottom bracket to look like that, isn't it? Don't worry, my child, do that. Write it like that. Write it like that, but just take the negative out, meaning just write a negative outside. In that way, you're gonna have this canceling that. Okay, then you're gonna have minus x plus 1 all over minus y. Now minus and minus, they cancel, so what is it that you have? You're gonna have x plus 1 over y. Now let's remember that we said x is cos theta, so we're gonna have cos theta plus 1 over what? Over sine theta. What do you know? That should be equal to this thing. So it's all about factorization. Like I told you guys, you know, these trig identities, it's just factorization in disguise form. So if you know how to factorize, this should be quite easy. But you do need to know those techniques we told you about, to say if you see cos times sine, you don't you then change it to this one. But if you don't see it, you change to either of these, guided by what you have. Right, any question there? I hope we're okay. Right. Next one. Yeah. Hey. So this is what we have there, right? Yeah. Hey, when a question says, makes you say hey, you know that it looks somehow. But these questions in identities, they actually look very ugly, at the same time beautiful, at the same time easy. So what do? You just have to remember the principles, good people. The principle says, if I see tan, I'm gonna probably change it to a sine over cos. But I'm not saying always, but in most cases it's beneficial. That's why I said we must play chess. We must think of it as if we're playing chess. Because why? You must always ask yourself this: what would it benefit me to change this tan into sine over cos? How will I benefit from that? You already think of it in your mind that actually if you do that, you would have changed this into sine x over cos x. You would have a fraction here. Over here you have sine. So having a fraction there means you can actually combine these two. You can combine those two. For this to make sense, I'm going to take you back a bit to grade 3. If you can remember in grade 3, we used to solve things like this. 1 over 6 plus 2 over 6. What would we say? We'd say, the denominators are the same. So I'm going to say 1 plus 2 over 6, which is what? 3 over 6. Perfect. If I had 5 over 7 plus 1 over 7, denominators are the same, I would simply say 5 plus 1 is what? Is 6 over 7. But what if I had to add 3 over 4 plus 1 over 2? What would I do now? Denominators are not the same. Now, if denominators are not the same, what do? Please, good people, listen carefully to how we combine the fractions. once you have fractions, good people, in identities, combine the fractions. How do you do that? I'm gonna have a nice flow diagram here. You start here, you go there, you multiply those things, then you get your denominator. So you'd say 4 times 2. Then you go on top. Good people, please look at the arrow. It says I will start here, I'll multiply there. Oh, one of my grade 10 learners said, oh, we're just simply cross multiplying. Yes, we are cross multiplying, but we start from the right to this part. On top. So you'd say 2 multiplied by 3, and then you say 4 times 1. Okay. Oh, you say there's a plus, right? So it's plus, then you say 4 times 1. It's very important to follow that order. You start here, you go there, and then you multiply this by that. Please, let's remember that. Then you would have your nice X-Men. So now that would be 6 plus what? 4 all over 8, which would be 10 over 8. Okay, so that is how we deal with fractions. In a similar way, that is what we're just simply going to do here. Obviously, the juicy part is the left-hand side. So you're going to say, on your left-hand side, you have tan x minus sine x all over sine cubed x. Don't be scared about this thing. Let it not scare you. So now that you have tan x and minus sine x, you can write that as sine x over what? Over cos x, and then minus sine x all over sine cubed x. Now, good people, this is a fraction, but this does not look like a fraction. Well, actually, it is a fraction because this can be written as over 1. Please, let's remember that. So now our next task is just to combine those fractions on top. So you would simply have what? You simply have cos x times 1. You say cos x, you multiply it by 1. Then you say 1 multiplied by the sine. So let's just do this mentally, good people, to save time. Cos x times 1 is cos x. 1 times sine, it will be sine x. And then you have a minus sign, and then you say cos times sine. That will be what? You can write it as sine x cos x. Right. Then remember that all of that is divided by sine cubed x. Now usually when we have the numerator as a fraction, for you to make your life easy, try to change this sign into the normal division sign we learned in lower grades, isn't it? So try to write it as divided by sine cubed x. Well, what do you know? Remember, this is sine cubed x over 1. When we divide by a fraction, we can flip it, right? So this can be written as sine x minus sine x cos x, all divided by what? By cos x, and then multiplied by 1 over sine cubed x. Now you can already see there is a certain pattern here, because if you multiply the whole of this by 1, you are simply going to have sine x minus sine x cos x divided by what? Cos x sine cubed x. Now, who can see the type of factorization we can actually do here? Does anyone see where we can factorize?
Can't we take sine x in the numerator?
Yes, we can take it as a common factor, right? And remember, taking it as a common factor shouldn't be that difficult task, meaning you can write it as it is. You write it as it is, and then you simply divide by that sign, the common factor. Divide by sine x here, you divide by the what? By the sine x here, and then you take it out and multiply by it to avoid making mistakes. And then you divide by that cos x sine cubed x. Right, let me try to remove this part so we can continue there. So now that you would have that, now it means outside you have sine x And then now this one, when they divide each other, you get 1. So you're avoiding this thing of saying, when I take sine out, I'll be left with 0 there. You see? Then you have minus. Sine and sine divide, you are left with what? With cos x. You do it nice and clean without having to think too much hard. Now, cos x, good people, sine cubed x. Let's remember that sine cubed x, I like to expand. It will be sine x times sine x times sine x. That is sine cubed x, isn't it? Why am I expanding? Chairs, good people. You think I hate to say, if I expand it, I will be able to cancel one of the sine, isn't it? Then what will you be left with? You would be left with 1 minus cos x divided by what? By cos x. And then now remember the sine and sine, what do you get? You simply get sine squared x, isn't it? You get sine squared x. Then you look at your problem and be like, Clayton's method, they don't work. I knew it. But they are not the same, those things. They are not. Why is he doing this? So they are actually the same though, right? Why am I saying that? Well, this is because you can, what can you do there? You can multiply, you can try to simplify this part to see if it's not the same as this one. But I do see what they did there. Okay, so let's take the right hand side, because now that we are done with this one, we feel like we are done. And now it doesn't look like there's anything much that can come from this. But is that true? I mean, remember, we said that you must remember that sine squared x, let me take you back here. Sine squared x, remember, where did I write it? Oh, hey, I thought, I think I removed them. Sorry, but if you can, yeah. Okay, so if you can remember, guys, I did say that let's know that sine squared x can be written as 1 minus what? 1 minus cos squared x. Do you still remember that before when we started? So that is what you're simply going to do here. You have sine squared x, you can change it to this. If you do that, what are you going to have, right? You're going to have 1 minus cos x. Whenever you feel like you hit a dead end, remember your identities. So you're going to say cos x into 1 minus what? Cos squared x. It still looks like we hit a dead end, but we did not, good people. Why? Because 1 minus cos squared x, the nice thing about this is that it will always be a difference of 2 squares. You understand me? Because 1 is a square number. Cos squared x is also a square number. So it can actually be written as 1 minus cos x, 1 plus cos x. Isn't it? So that's what you would do there. You have 1 minus cos x, right? All divided by cos x. So you'd make it 1 minus cos x times the 1 plus cos x. Then what is going to happen there? 1 minus cos x divides the 1 minus cos x. Then your answer should be, on top you should be left with 1, at the bottom should be left with, so it will be exactly this thing. Then you would say it's equal to the right hand side. Okay, don't forget to say it's equal to the right hand side. So that is exactly it. That is exactly it, guys. It's all about using those identities. Let's go to the next one, see if we're able to apply this. Yo. Hi. Now I don't know what I was thinking when I was choosing these ones. They seem quite difficult, isn't it? Hey, they seem quite a lot. Hey, Bona. Where do we start? And it's just equal to sine. Sure. then you just leave it. No. Yeah, I know someone who's like, Clayton, why would I focus on things that are difficult when I can just go to others? Yeah, a very, very good strategy. But you can give them a try. To say maybe the left hand side, right, would be equal to sine 2x all over cos x. Yeah, 1 minus cos 2x. And then you have 1 plus 1 over tan squared x. Right. Shoo. Guys, do you think this thing has a solution? Because I'm feeling scared just by looking at it. It's scaring me. It's really, really scaring me. But it's not difficult, right? It's not. You know, some things you just have to take them step by step. So you already know on top that you have sine 2x. Norma kanjani. You must change that one to what? To 2 sine x, right? Cos x. Even if you were not able to do others, at least you know you have a mark there, isn't it? Right. Then you have cos x into 1 minus cos 2x. Now, do you see that there is a 1 here? You see that there is a 1, right? Good people, if you have a fraction plus a number, those things are actually both fractions. Just like we did in the previous one. Do you still remember that we had, I think it was sine and then it was then tan? We actually said we can combine them. In a similar way, you actually can combine this one here, right? Remember 1 plus, that can be written as 1 over 1. And then you have 1 over tan squared x. Now here, good people, do not be too quick. You can though, but don't be too quick to change the tan squared x into sine over cos, because you need to deal with it first, maybe. Or maybe you can actually do it. In fact, let's just do it, right? Let's write that as 1 over sine squared x over cos squared x. Right? We changed it. Now, when you have a denominator as a fraction, I always say you can simply take the denominator on top, or you can think of it this way. If I have x over y, I can write it as x over this one. Then remember, multiply by the bottom denominator. If you can still remember our last video, right? So this is the same thing here. You would say 1 over sine squared x multiply by the bottom fraction, but only if the denominator is the one which is a fraction, not if the numerator is a fraction. Only when the denominator is a fraction, because we know if the numerator is a fraction, like here, if the numerator is a fraction, then we have to change this sign. Then we have to change this sign into the normal division sign. But if our denominator is a fraction, we can say 1 over this first numerator multiply by the bottom denominator there. So this is what you simply have, and you are just doing this with a pencil on the other side just to get what is going on. And then you have cos squared x over what? Sine squared x. Then now that it's like this, you can combine. Remember the sequence? 1 times sine, it will be sine squared x. Sine squared x times 1, it will be sine squared x. And then 1 times cos squared x, that will be plus what? Cos squared x. No one would penalize you for working on this one first. No one will penalize you for that, because you just want to put your answer here. So you actually can do it on the side. Now, sine squared x plus cos squared x, good people, do you still remember we said that is equal to what? Yes, I know you are shouting in your head that we said it's equal to 1. So you have 1 over sine squared x. Now that is what we can write here. 1 over sine squared x. Now we have killed this bracket, right? It looks a bit more friendly. Now what do we do? Good people, because I expanded the top part, can you actually realize that cos will actually cancel the cos at the bottom, right? We'll divide the cos at the bottom, so meaning that you will be left with this so now you have 2 sine x divided by 1 minus cos 2x. And then I want you to actually check something out. You have sine squared x here, right? I want you to check something out. Is this denominator not a fraction? The denominator is a fraction. So what can we do? We can actually then say we have 2 sine x over that 1 minus cos 2x, then over 1 times the bottom fraction, which is what? Sine squared x, isn't it? Then in that way you're going to have 2 sine cubed x all over 1 minus cos 2x. Good. You are here now. Hey, you've worked. But you're not done, right? Because you still have a long way to go. Now we have to deal with this one, cos 2x, right? Remember, you can change cos 2x into 3 things, isn't it? So because you can change it to 3 things, remember it's always influenced by what you have. In terms of this one, you see what you have. You have sine cubed x and then that. So maybe you can actually change this into the one with sine, meaning that we can say we have 2 sine cubed x all over 1 minus in brackets, remember that would be 1 minus sine squared x. So in that way, what are we going to have? What did I change to? Why did I change to that? Because I have sine. I don't have sine times cos. I have only sine, so I have to change it to the one with sine. Then I'll have 1 minus 1 plus sine squared x, right? Then what do we have? Talk to me. Okay, I'm getting this, guys. So the final answer that I'm getting is 2 sine x. Did I do anything wrong along the way? Two sine x cos x.
I think so. Kappa, is it me? I think so. Because cos
yes.
is supposed to be 1 minus 2 sine squared x.
Oh yes, thank you so much. Thank you so much. Hey, it smelled wrong. I don't wanna lie to you. It did smell very wrong. Perfect. So actually here, you see now I'm the one forgetting our stuff. So it should be 2 sine squared x, right? So that we have 1 minus 1 and then plus 2 sine squared x. Then you'll have your 2 sine squared x, which will cancel the 2 there. Then you've proved it. Right. So what I can say to you is that every identity you are able to prove it. Hopefully that the person who came up with it made sure that it has a solution. Every identity you can prove it, but the methods of proving, right? I think you can see. From me, I can say the first thing is to know how to work with this one. Know how to work with it, know how to change it. Another thing is to know how to work with tan, to say I will change it to sine over cos. But another important algebraic aspect of things is that, please guys, know how to add or subtract fractions. If you know how to add or subtract fractions, you are good. Number 2, know how to factorize. If you're able to factorize using highest common factor, difference of 2 squares and the likes, you are okay. You understand me? And then the last thing is to know how to divide fractions, right? If you know how to divide fractions, you get the correct stuff. And then know how to work with cos 2x, of which working with cos 2x, I said to you, if you have sine x times cos x, you most probably have to change it to the first one. And another thing is that sometimes you can, I don't want to lie to you, sometimes it's beneficial to change this into cos squared x minus sine squared x. Do you know why? Do you know why? This is because this is a difference of two squares, okay? So you'd have cos x minus sine x into cos x plus sine x. So it's sometimes beneficial. You just look at the problem and say it can benefit me to actually make it a into that form. Usually it will be because maybe on top you have something like cos x maybe minus sine x. Then it means that if at the bottom I have cos 2x, I must try to change it to this one so that they can cancel. So it's all about, you know, trying to match what you have with the information that you know.